streaming. Oh, I got a lot of sneezing happening here. Woo. Hopefully I won't sneeze straight into the mic. That would be fantastic. According to this, I'm online. Hurrah! Let's go and tell the world. Streaming ProcGen Jam game dev with my new enloudened voice. I just finished lunch, or late breakfast, brunch. I just finished brunch, but hopefully I won't have any sort of obnoxious tooth sounds into the mic. You'll have to let me know. Now I want to go here and say the same thing. And then over here. And let's get started. I'll probably stream for 2 or 3 hours to try and get this planet generation system up and running. El Boechi's already in stream. Oh yeah, I guess that's true. A lot of my viewers are over in Europe, and to them it's actually a reasonable hour. I'm not going to get very many American viewers at 11 a.m., so, or even earlier if they're on the West Coast. But over there in Germany, it's like 4 or 5 or something. Right, so this is where we left off with this random thing, and today we're going to do a lot of stuff. We're going to try and get this to a fully serviceable planetary generation system. I don't know whether I can do that in 1 session or it might take 2, but I should be finished today. And I might have a little bit of a coughing thing because I ate some slightly strange stuff. It was good, but it was a little strange. So my throat's like, oh, I'm not sure if you really wanted to eat that much jalapeno and fish quite that fast. But the rest of me is like, yeah, I did. It was good. So what we're going to do right now is we're going to do the phase in. So what's the phase in? Well, as you can see, I've set the height and width up to 1024. And if I hit run, well, I need to hit randomize because otherwise you won't be able to tell. If I hit randomize, well, you can see that 1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi, 5 Mississippi. That's unacceptable. So what we're going to do is we're going to do a phase in thing where it doesn't calculate out the whole thing at once. Reaganomicon says 8 a.m. crew and salutes. So he's on the West Coast and West Coast of the U.S. And apparently is watching people stream it early in the morning, which I guess that's your choice. It seems like a huge waste of time, but you know. Processed pixels. So what we're going to do is we're going to have a couple of things here. We have a bunch of options as to how we want to do this, but I think doing it during update is probably best. So here we've got run, and what we're going to want to do is create a variant of run which processes based on some kind of... No, I've got the hiccups. Great! So we're going to create a version of run that jumps by a certain amount of... These are all public, but we need to hide them in the inspector. Or else we'll screw up later. So this is going to be a step size. And we'll want to have a step size that's a power of 2 so that we can divide it. And here we've got a run, but what we're going to really want to do is set that up to run with a specific texture proxy, or not, every frame with a decreasing step size. So we're going to need to store that texture proxy render target. Actually, we don't need to do that because the version that we run from the so I'm catching up with my own thoughts here. Reaganomicon says he's babysitting bits of metal. It's either this or reality TV. And as he said that, my stream froze. So hopefully you guys can still see it. So I have this run and I pass it null. Null means please process every texture proxy. Here is the run where I take in a texture proxy and then I check if it's null. Here's the thing, if I'm taking in a texture proxy, I want to do it all one pass right now. Whereas if I'm doing it all of the texture proxies, I want to go through step by step and fill in every 64th pixel, then every 32nd pixel, and so on and so forth. So to do that, I need to split this back out into two different functions. A processed and a whole bunch of other. I need to split it into several different functions. And right here where we go through all of our x and y coordinates and we say proxy.process, I'm going to want to rethink this. I think that what we're going to want to do is do all the pixels for a specific proxy rather than go through all the proxies per pixel. And the reason for that is just because that way I can put it inside of a different loop. So we'll do that down below run. We'll go ahead and say public void process map. And we'll do a render texture target proxy. Not a render texture, sorry, a texture proxy. I haven't really been doing anything mentally challenging this morning. I've just been buying coffee and fish. So it'll take me a little bit of time to get up to speed. You're seeing me at my dumbest, but that's fine. So what we're going to want to do here is go through all of the pixels for our proxy. And that's quite easy. We'll just do it like this. We won't want to do the apply, though. We'll do that outside of this process map. So we go through all of these width and height, but what we're going to want to do is add our step size instead of 1. So we'll just go ahead and say plus equals step size and plus equals step size. Let's go ahead and make this a little bit bigger so that people can see it. There we are. And here we're going to go ahead and just take this out and say target proxy dot process x, y, this. And then we're not going to want to do this tint by height here because that's also something that's going to happen outside of this situation. That's not how you spell target, targetet. So now we can process based on any given proxy and any given step size. So what we're going to do is we're going to create an update function, which we'll call this with progressively smaller step sizes. But we also want to make sure that if a pixel has been processed, we don't process it again. So in order to do that, we're going to say if processed pixels x plus y times height width is greater than, or is true. Yeah, so just that. Then we want to continue. Don't double process. Now we don't set those values here because we're currently going through the target proxy one by one. So we don't want to set it here and then fail to put any other target proxies in. In fact, it may be better if we do go back to making it so that all the target proxies happen at once. The reason I didn't want to do that was so I didn't have duplicate code, but I'll be honest, duplicate code isn't so bad, especially in a Game Jam game, so we'll go ahead and just set this up and then turn processed pixels to true. And we'll also put this back in. So let's go ahead and do a little bit, tiny little bit of making this more readable. And then we'll use index and for these instead of repeatedly multiplying out this large value. Now this is possible to optimize substantially more than we currently do, but I don't care. And we'll need to put the black color in here as well. All right, so this will process all proxies by a certain chunk size. And that's fine. So what we're going to want to do is create an update, public void update, which will call process map, right? Process map. But it will only call process map if we're not done. So if step size is greater than 0, process map and then divided by 0. Or divided by 1, divided by 2. So step size is an integer, and so dividing it by 2 will eventually reduce it down to 0, at which point we will stop processing. Simple enough, right? So up here in our primary process function, we're going to want to do two things. In this, we're going to want to go ahead and set up our step size. Step size equals 64, process map. And that will kick off our processing. And it should be fairly straightforward like that. Let's see if we're forgetting anything. We do need to have these here. So we'll grab these and drop them into that same function. So we're initializing our all of our textures if we need to, and then we also need to set up our new field, which is our processed pixels list. Now there are mathematical ways to do this processed pixels stuff instead of just having a big list of bools, but a big list of bools is real cheap, so I don't care. We're just going to have a big list of bools. And then we're actually going to want to redo this bool every single time, just so that it gets reinitialized to false all the way down. Elboetchi's like, duplicate code. So the reason I need the duplicate code is because this texture proxy here, where we can run for a specific texture proxy, this is built for sampling a given noise field. So we need to run it in one frame, and we don't need to run it on any other proxies. So we're just going to go through and do this. And don't need to tint by height, so it's just going to be some duplicate code here because it doesn't matter. Now this set pixels, these things here, these also need to be put down into our update code for the processing. So what happens is after we do a processing list, we're going to want to set the pixels correctly, and then we're going to want to make sure that the material property block correctly has those values set up. Now we are creating duplicate property blocks with every frame using this method, but that's not really a big deal. Property blocks are really, really small, so I'm not too concerned about it. I can always optimize it later, I suppose. Now we're going to look for errors. Oh, I don't have an error, but I do have something I can optimize away, so we'll go ahead and do that. I don't need that black base coat for just sampling noise. So there we are. So now what we should be able to do is tell this to run, and it should give us garbage. And the reason it should give us garbage is because we're not actually running frame by frame. So we're only going to get the first pass. Yeah. So then you can see that what we've got is every 64th pixel. So what we need to do is have this run differently depending on whether or not we're in edit mode or in running mode. But one of the things we can do is we can just run it and watch it. See how it's slowly evolving in? So one of the things I think that's going to be an issue is that I think that applying this texture might actually be very expensive. But it might just be that I'm doing too many of these at once. So the step value right now is doubling, which means that there is halving each time, which means that at the very end it is going one by one, and it's doing every other pixel. The problem with that is every other pixel is a lot of pixels. It's 1024 by 512. Actually, I think it's even more than that, because I think it's every other pixel on every other line and every pixel on every other line. So it's a lot of pixels. So what I really need to do is change the step function so that it is a little bit more useful. And so what we're going to do is when we do this step size thing here, we're actually going to only have it process the step size on the y-axis. Even that's not great. So instead what we're going to do is we're going to have, should we have a, well, let's go ahead and try it like this for now and see whether or not this works. Twitch is completely dying. Do I need to bounce the stream? I've only been running for 15 minutes. I can bounce it if I need to. It's not a big deal. If another viewer is having an issue, please let me know so that I can bounce it. So that's quite slow. And I think that the problem is that we really want to do a scan and pan sort of situation. So we'll do that. We'll set this up with a scan and pan. Counter. So what we're going to want to do here is, instead of testing the step size, we're going to do testing on the scan and pan counter. So down here, what we'll say is when we're processing in update, we're going to want to do a scan and pan counter is greater than 0, scan and pan counter minus minus. And that should allow us to process through every nth line. So here we're going to go ahead and say y equals scan and pan counter, and then y plus equals step size. And that means that we'll have 64 passes, each of which do height divided by 64 lines. So let's go ahead and take a look at that. Oh well, but it says it's a problem on his side. I think that's what he's saying anyway, rather than being my problem. So you can see how there's no delay on this, but obviously it's quite slow. That's fine for now. I can just change the step size. In fact, I have the step size as a public variable. I might as well just show it. So right now it's set to 64, but I can change that to, say, 16. I also don't have to have it divisible by 2 anymore. There's not a big, no big reason to do that. I think that right now we've got a problem where the hide in inspector is actually causing it to move slowly. Okay, so that felt real slow. Let's try that one more time. Yeah, that's real slow. I mean, I guess it's not too bad, but I'm not sure whether or not it is the apply function that's causing us problems, or whether or not we're just processing too much and I've got too much of a load on my computer right now. Either way, it actually takes about the same amount of time as it did when I was computing raw. Watch. So if we hit play, and then I hit run, 1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi, 5 Mississippi. So it takes like another second past what it used to take, but there's not really a lot of slowdown, and you get that feedback that something's actually happening. The problem is that if we're not running, that doesn't happen. We just get every 64th line, and that's it. So if we're not running, we're going to want to have something else happen here. But another thing we can do is, instead of having this be white, we can fill it in with the colors. We can just create extra rows. So to do that, what we're going to want to do is create an inner loop here for int y equal int z, int dy equals y plus 1. Right? Y plus 1? No, we want to make it y equals dy equals 0. Dy is less than scan and pan counter, dy plus plus. And we will set the albedo pixels, these are the only ones we care about right now, equal to the albedo pixels of the index point. So albedo pixels x plus dy, index plus dy times width equals albedo pixels. So this problem here is that we actually need to make this more annoying than it currently is. We actually need to have this subtract out values. So what we're going to want to do here is actually set this equal to negative scan and pan counter and make it so that it keeps processing as long as dy is less than 0. And that should work. So that should fill in these white gaps even when we run it in this mode here. Boom. And you can see that all it does is stretch all of those lines down. But when we're in play mode, that actually will look okay, right? Ooh. That was interesting. That's not what I expected to see. So scan and pan counter is decreasing, right? So when we have it at negative whatever, it should slowly reduce the number of passes that it does, because it should start at negative 15, negative 16, negative. No, it still looks wrong. What's weird to me is the way it's crawling left, because that doesn't make any sense. This shouldn't crawl left. How about dy equals 1? dy is less than scan and pan counter. dy plus plus, and then we can just do a minus dy times width. This shouldn't be this hard. I don't know why I'm having a hard time with it, but the first thing I'm going to do is move the camera so that I can actually see the planet without switching back to scene view all the time. Bump, 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 bump. No, it's not working. I mean, I can just go ahead and fill it in with default color instead. I guess that's probably better because this is taking too long. So what we'll do is we will have a default color that we fill the planet in with. Right now we have a default starting height. We need a default color. We'll just set it up as color.black for now. And then down here, when we actually reset these values when we run, we're going to go ahead and set all of the values to the starting color. So for int a equals 0, a is less than, we can actually do it in here. Default color equals this. All right, so what we're going to want to do here is change our, well, this never worked in the first place. Great. So this is going to be color 32 height map default equals new color 32. Starting height 255, 255, 0, 255. There we are. Because the R value on the height map is in fact the height, not the A value. That was the old way that we gave up on. So height map default is not here. Great. And we're going to want to use the color that we just created here. There we are. And that should create a nice set of default values so that we don't have to constantly worry about that. But on the other hand, since we do have a loop like that, we might as well put processed pixels in there as well. So when we hop our way back over into Unity, we should now be able to see this happen in real time and not screw up. I didn't tell it to run, which is why that happened. But you can see I've got a line left over, so I'm going to want to figure out what's up with that one line. Probably just need to do a greater than or equal to instead of a greater than. Oh, no, this time it worked. So what happened is I ran it in editor mode, and then it caught up in run mode, but I changed some of the values, so it got all screwed up, but that's fine. All right, so that's good enough for now. What I'm going to do is I'm going to just switch this back to 512 for the sake of having things work quickly. I'm almost convinced that what we've got here, this really, really slow processing, is because I've got some hide in the inspector calls for these huge objects. And I think that a better option for us is to make them getters and setters because that's really slow and annoying. So we're going to go ahead and make these... we're going to need these in two places. We're going to need them to be underscores and also the real ones. So we're not going to need to worry about this. We'll go ahead and make this protected. Nobody's asking about that. But these, we're going to need a duplicate that is underscore and is protected. And then these can be public, but they're not going to be variables. They're going to be accessors. So return height map pixels equals value. I think I can just do this. I don't think I have to worry about the fact that I'm accessing them in array form, but we'll see. If I do need to do more work here, I will. But I do need to make sure that I spell things right, because if I change the wrong thing, I'll be confused forever. There we are. So let's see whether or not this works. You gonna barf? You gonna barf? No, you're not. Okay, good. So what I want to do now is run this while we're in play mode. So if processed pixels index. So for some reason, processed pixels didn't happen that time. That's interesting. The scan and pan counters all screwed up. So the problem is I was doing a lot of crap in edit mode, and it's not really compatible with edit mode anymore. There we are. Zwamp. 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 And if I change this to 1024, it happens instantly. I don't know why hide in the inspector is so slow. That's dumb, but it is, so we'll leave with it. Yay, there we are. So we've got it working just fine now, and what we're going to want to do is start to create some fun planet sort of things for this. But in order to do that, we're going to want to make it work here in scene view, because if it doesn't work while we're not playing, it doesn't work. I don't know if you've noticed this, but my color modifier for being in play mode is gone again. That's because Unity is incompetent. Let's see if we can get that back. I rather like having my color mode for in play mode being noticeable, but for some reason, I don't know if it switched back to gray or if I never made it. Yeah, that's more like what I like. That's good. So now we're going to go ahead and make this work in non-play mode. And the way we're going to do that is down here in run. What we're going to do is we're going to set the scan and pan counter equal to, first off, it's going to be equal to the step size, not to 64. That might be the problem we've been having. And the other thing we're going to want to do is set it to 1 if we're not in play mode. So if application.playing, do this, else scan and pan counter equals 1. And then, of course, at the end here, we're going to want to clean that up. Now, this is a brute force technique, but that's fine. It's a game jam. We can use some brute force techniques. And then if we hit run here, it didn't work. Oh, I bet I didn't let it recompile. I bet that was the problem. No? Oh, I know what the problem is. I told it to only process every step size. So we're actually going to want to reduce the step size and then bring the step size back too. Great! Make it more complicated. As complicated as we can, right? So we're going to make the scan and pan counter equal to 0, and then the step size equal to 1. But we're going to want to store the step size so that we can bring it back later. What an annoyance. This is something where I really should have another way of doing this. It doesn't suck as bad, but whatever, right? There we are. All right. So now that we've got this working in non-play mode, in edit mode, we can start to create some values for our game that will make sense. And we're going to want to come up with packages of refinements so that we can just kind of create lump values for this system. Right now we've got this continental plates, this game object here we're going to disable. And we're going to go with just raw height map. No, not play. Idiot. Boom. Run. Oh, because it's no longer, these are no longer saved while we're in play mode. So I need to check and make sure that these actually work. Or not, or height map pixels equals null. That's interesting. We shouldn't have any possibility of that happening. I think what I've done is screwed this up somehow. So we're going to go ahead and set that to none and try again here. All right. So I don't know exactly what I did, but I goofed. So here you can see that we have a problem because our default color is black. And that means that we can't see what's going on. But we can turn on the show height map here instead. And now when we run it, we should see the height map. And you can see that what we're getting at. So what we need to do is make this height map have some different values to it according to what we would like to see. So the first thing we're going to want to do is take a note that our starting height is 255, but our raw continents overrides rather than adds. So what that means is that we're really going and we're just saying use the basic noise here. So instead we're going to switch this to add, and we're going to come over here to the continental plates planet. We're going to reduce this down to like 100, something like that. And now if we run it, we're going to get a very different result. So you can see that what we have here is some dark space down here. Now you might be wondering, why is there this blue, this weird chatterbox blue? That's because we've got roughen edges and sync edges both processing as well. So if we turn these off, we'll lose that chaos. Yeah, so you can see that we just have this pasty blue color down here. It's because red is our height. And if we don't have any red, then we don't have any height. So with that in mind, we do actually want to do a whole bunch of other things. Well, we'll get to that eventually, but first let's go ahead and turn back on roughen edges. And we're going to go ahead and make this so that we can see the whole set with a starting color of gray, just so that we can get a good feeling for it without having to try and remember what white is. So here's what it looks like right now. One of our problems with the planet is that it's got a smoothness value that's high enough that we're getting some difficulty telling what's going on. So I'm going to turn that smoothness down. We're going to create a metallicity map later. And I know that you can set the smoothness using the metallic alpha or the albedo alpha. We're going to be using the metallic alpha for that. But we don't have to do that just yet. So the only question in my mind is what channel red? Okay, so if the metallic channel is going to be R, then we might as well just use G for our height, because that way we won't have to do any conversion later on. So as of now, green is our height instead of red. But we do have to tell the world about it. So we're going to go down to where we grab height, and we're going to change this to green for every instance where we're looking for height. And I think that was probably the only instance. Oh no, we also do it over here in basic biome. So we're going to want to note down what our thoughts are before we get too far. So over here in our notes here, we'll just go ahead and make a quick note. The height map is R, metallicity, G, height, B, emission, and A, smoothness. There we are. And that should allow us to remember later on when we start to get confused as to what's going on. We'll just quickly check and see whether or not there's any more .Rs in our color. So here we've got another one. We need to fix this one as well. That's just the tint by height function. So that's the only .R left there. The only .Rs here are in the color adders, which are fine. And there's no .Rs here because that's the whole thing. There we go. So that should work out pretty well. We're going to want to allow our basic biome to actually have an R and a B and an A. It doesn't need to have a height modifier, but it needs to be able to modify the others. So we're going to go ahead and make those values ones we can punch in. So public bool apply color equals true. We'll have public bool apply metallicity equals false, public byte metallicity equals 0, public bool, I'll give it a range 0 to 255. And then we'll go ahead and duplicate that for emission. And then lastly, we'll do it for a smoothness. Now we could do that by having a color and then just ignoring the green channel of the color, but that would be hard for me to personally remember. So therefore, I'm not going to do it like that, and we're going to do it like this instead. Now, in order to do this, what we're going to want is to make sure we have some gates here. So if apply color, then apply the color. If apply metallicity, then we're going to want our height map pixels. I don't know whether we can modify them like this. Well, I suppose we'll find out. Equals byte.lerp? There's no byte.lerp. Okay, so we're going to need to have a byte lerper. Does a texture proxy have a whole bunch of... No, it doesn't. We'll go ahead and put in a byte lerp. Public byte byte lerp. Byte start, byte stop, float %. So here we'll just put in some bounds. If we'll just use the math function for int.lerp. No, we could use float.lerp. Do we have it seems dumb to use mathf.lerp on something that is, I guess we won't bother. So if % is less than 0, return start. If % is greater than or equal to 1, less than or equal to 0, return stop. Otherwise, we're going to want to return something between the two. The problem is that we don't have any sort of knowledge, any sort of lerping built in, so we'll just have to do it manually. So return byte of float start times 1 minus % plus float stop times %. And that should do. So that would let us do a byte lerp in here. So byte lerp. And we'll do this guy. No, not the whole line, just that one little piece. Metallicity and volume. And we'll just repeat that here and here for apply emission and apply smoothness. This will be B and this will be A. There we are. So that should work if it lets me do it like that. Hey, it did. Okay. Sometimes it doesn't. It depends on whether or not the color 32 is considered a struct in certain locations. Yeah. I don't care. As long as it works, it works. So what we've got here is the ability for our biomes to create any values we want. The problem is that right now we're not assigning those to the metallicity map. So what we need to do is over here in our planet, at the end of this, when we are assigning these property blocks, we're going to want to assign the various pieces that we need separately. So public void create property block. And we'll just drop this property block stuff in there. Because we're doing it in 2 places and it would be obnoxious to do it in 2 places, so we're not going to. Perfect. And so inside of this create property block, we're setting the main texture, and I know the name of the main texture, it's main text. But you know what I don't know the name of? Anything else. So the problem is that it's very difficult for us to see what those values are normally. But here's a trick. You can just right-click on it and have it tell you all of its values. So here we've got color, main text, cutoff, glossiness, glossiness scale, smooth, metallicity. So here it is. The metallic gloss map is probably what we need. I don't see any other map that it could be. Now we do have an emission map that we're going to have to build separately if it is a planet that has emissions. But we're going to go ahead and assume that this metallic gloss map is what I need. And it's a good thing I looked it up because holy crap, that is a weird name. Metallic gloss map. And that's going to be our height map. Now we actually called it height map, and there is something called a height map in here. The reason that we're not using that height map as a height map is because we're not going to be using the height function. I don't think it works right. If it does, I've never managed to see it looking right. We're probably going to be converting it over into a bump map, and then we will just be sending it over as a separate file, a separate render texture. For now, however, we'll just go ahead and keep using it as we are. And if we go back over to our low poly planet and we run this again, you can see that there is no change. Not in the scene view, but now the reason there's really no change is because we aren't actually doing any of this stuff very carefully, but we do have it set up here, as you can see. So at the moment, we're not assigning those values, and so I think they're just set to 255 for everything, which is a little strange. Let's go in here and set them to something that's more dusky. So here's where we set the height map default. We got R, this is metallicity. We got G, it's height. B, emission. And then this is smoothness. And we'll go ahead and set smoothness to something kind of halfway down. So now what we can do is run this again. And you can't tell the difference. I'm actually not even sure it ran. Great. Well, we can put in some biomes to set this up a little bit more interestingly. But for now, I just wanted to take a look at this and have it set up so that our height map is working. So now that I've got this, I can set up the sync edges, and the sync edges will end up crushing a lot of those edges down. But the edges of our planetary continents here aren't really very sharp. We would really like to have them feel more wobbly. So what we're going to want to do here is for our rough edges, we're going to go ahead and reduce the noise amount. And then what we're going to want is to have that, see if that works partially. Is that really purlin? That looks like swirling. It's purlin. Oh, the noise map is... Oh, I see. It was maxed out at 0.5. That's probably what was going on. So what we're going to do is run this. And, okay, so now it's all chaotic and mubbly. We're going to go ahead and have that, just adjust it until it feels right. So I think that we did the wrong direction on that particular curve. We randomize this and aha. So now we're starting to get some edges that seem a little bit more fun. But the rough and edges problem here is that it's applying to a height that's a little bit weird. So we're going to go ahead and just put it like this. And that means that we're going to have maxed out height continents, but that's okay. We can put in some details on those continents later on. And you can see that now we have wobbly edges on our continents, as well as some stuff happening in the oceans. So because of that, what we're going to want with our sync edges is something a little bit more interesting. So if I go over here to the planet and I tell it to run, you can see that basically all sync edges did before is darken the deep pits. We're not going to want it to do that. We're going to want it to darken the mid pits. So our noise map is fine, but our height map is wrong. So we're going to just drag this up. There we go. All right. So is this flat? It's purlin. That's the problem. We want it flat. Boom. So now we've got continent features. We can adjust the exact sizes of the continents and stuff, but you can see that at least that looks like continents. But we're not quite done yet because we're going to want to have some crevices, some continental crevices. So for that, we're going to want to go ahead and put in some serious stuff. We're going to use some swirling, and we're going to apply to height only to the deepest parts of the ocean. We're going to subtract out, and we're going to have our noise map be like this. And then we're going to go ahead and see how that looks, because that should give us some nice deep cracks in our planet. Okay, so it didn't really create any deep cracks, presumably because we'd already flattened it down using sync edges. I think that this is already at height 0, so that's why we're having this issue where it's not properly working. So what we're going to actually want to do is raise basin, and then we'll go ahead and raise the basin to be adding to a height map like this. And we're going to want this to max out at 0.2. I can't tell if that's 0.2. Come on, give me more space so I can see what's going on, Unity. There we are. All right, so if we raise the basin and then crack the ground, we might get something good. Let's try it out. All right, so here you can see that we've raised the basin and then we've cracked it down again. Now, it doesn't seem like much at this point because it's just a raw height map, but we'll be filling in these values with some really interesting stuff, so that'll be fun. What we're going to want to do here is really reduce the scale on this swirl and noise. Is this right? You know, that sampling doesn't work anymore for some reason. I'll fix it later. So what I want to do is I want to make this really, really, really crisp. So, like this. Ah, there we are. So we're going to go ahead and try and get some cracks like that. It doesn't really matter whether they look good or not, as long as they exist. Now, what I've done here is I've created continents and oceans as if there were going to be things in these oceans. Now, the question is whether or not I want this to be separate from the biomes, because I can also create the biomes. The rough and edges, I think we're going to go and change these just a touch. But we want to add in biomes, and I think I'm going to make them biome free, and then I'm going to add in the biomes as a separate operation, which you can see me doing here. So what I can do for these biomes is I can add in an ocean or something similar using just a set of situations. So we're going to go ahead and call this the ocean biome. And the ocean biome's purpose is going to be to fill in the water. Boom. But what we're going to want to do with this ocean biome is it's going to want to be shiny and a couple of other things. So we're going to want to apply a metallicity and apply a smoothness. And then if we run this, we should hopefully have a different amount of metallicity and smoothness. But I don't see it. Because metallicity and smoothness should be one of the things that actually do change. So here it is, the metallic map. So red is metallicity, and alpha is smoothness. This doesn't show alpha here, but you should be able to see the red. But I don't have any backdrop. I don't have any sky map, so metallicity is not really very metallic. We're not going to see very much, but I'd like to at least see the shininess. That's interesting how I can't even see the shininess right. Well, we'll go ahead and see what happens when we do the opposite on the areas above. So here's the ocean. We're going to want to add another component for the non-ocean sections. So we'll go ahead and add in another basic biome. And this basic biome is going to be for our non-oceans. And that's going to be an opaque, slightly yellowish, reddish gray, like this. And we're going to want to apply a metallicity of 0, an emission of 0, and a smoothness of 0. And we're going to apply that to the opposite height of the ocean. Okay, so you can see that we have some issues here where it's applying across the top of the ocean. So I did that on purpose because I wanted to experiment with what this looks like when I reverse them and add the ocean in second. All right, good. So it does work the way I expected. So the point of this is that when you're exploring planets, there's going to be some fun biome stuff here, and I want to be able to randomly add in biomes just in chunks like this. Now, the ocean biome doesn't really need to have a top biome here, but we could add in shallows instead. So if we were to remove this component and then add in another basic biome, this could be our shallows. And our shallows would be a brighter color. And then our shallows are going to be applied in this sort of middle range here. So let's just go ahead and pop that up. You can see that we have these shallows being applied, but this is a very narrow band. Let's go ahead and expand that band just a little bit down below 0.4. Maybe like this. Okay. Trying to see exactly how I want this to feel, and it's a little bit strange to try and get this to work with just, random thoughts in my head. I think that I need to make this much, much smoother so that it doesn't have quite that kind of crisp, super sharp feel. Well, that's a little bit too shallow. Well, this is pretty good, I suppose. So now we've got some basic planets with this is going to be an ocean that's not frozen. It's quite solid, but we have one more problem with this. Planets are not universally warm. We're going to want to have an ice cap function here. Right now, we do not have an ice cap noise type, so we're going to go ahead and add one. And we're going to do that by opening up basic noise and adding in a new source. And that's going to be polarity. I don't know what you want to call it. Polarity is a dumb thing to call it, but basically we need to get a value based on how far from the equator you are. So down here in our noise system, case polarity, and we're going to want to return mathf.abs pause.y. Now, to be honest, that creates a value that is just always going to be between 0 and 1. In the previous version of this, I went out of my way to create variations on that so that I could have different kinds of polar caps. But in this case, I can just adjust the polar cap directly using the noise map. So we can go ahead and add in an ice cap as a separate object here. So we'll go ahead and just add in a noise field up at the top here. And this will be our polar cap. And our polar cap is going to be polarity, and it's going to be an add, and our noise map is going to be like this. And then what we're going to want to do is our basic biome, we only need one, is going to just be ice. Now, the problem is that it's going to apply to everything that's at height 1 if we're not careful. So we either need a way to distinguish between different heights, or I need to flatten the planet a little bit and then apply the height map. But let's see how it looks just with it being applied raw like this. So we're going to want this to be not super smooth and not metallic. The biome color is going to be a frosty, frosty white, light blue. Now if we run this, we should see polar ice caps. Yes, we do. They're not very big. And that's just because of the height map converter I used. But you can see that a lot of land turned icy. The question is whether or not we want that, because that is quite icy. So we may want to duplicate this as another basic noise element that we put in first. We can just lower the entire planet slightly. So if we have a noise map that is set at 0.1, there. That'll lower the whole planet by 0.1, at least in theory. And that way we will be able to then process it. So we can also just apply that to only the things that are tall. And that way we won't have the whole planet get icy. We'll just have the polar ice caps. But we're going to want our polar ice caps to be a little bit better than this. So we're going to pull this back. And then we're going to go ahead and put this here. Because that's the height, so that should work. We'll try this out. All right, so we still have a lot of height being applied to the planets, to the surfaces here. And the problem is that that's too much ice and too little ice field. So what we need to do is have our ice field get applied in a much more intelligent way. So first off, let's go ahead and make this a little bit stronger. And then what we'll do is we will have our basic noise here. We'll have it be applied a lot more strongly to things that are lower in terms of their height. So if we do it like this, then we should be able to get stuff that raises the ocean right out. Yeah, that should work. Let's try it. Boom. Okay, so we have the planet behaving as I would like, but the ice section isn't icy enough. We're going to want to raise up that even higher to push it to be more in tune with what we want. We're probably going to want to adjust our noise map to be a little bit more like this. And then we're also going to want to have this be higher than 1, like that. Lastly, we're going to want to adjust our basic noise, our texture proxy actually, with a notes field. Lower the planet 1.15. Ice over north and south poles. Ice caps. All right, there we are. That's more like what I want to see. Now, the only problem with this is that it's extremely regular, and that's not actually unbelievable, but it's not as good as I'd like. So what we're going to do is we're going to add one more kind of noise, and that's going to be the polarity and purlin combined. So we're going to call that polar purlin. And the polar purlin is going to be the exact same thing, except for we're going to go ahead and moderate this with purlin. So what we'll do is we'll multiply it by the purlin result but we're going to modify the Perlin result a little bit. So this is going to be a value between 0 and 1, but what we actually want is a value between 0.5 and 1. So we're going to go ahead and multiply it by, and we're going to go ahead and add 1, and then divide it by 2. There we are. That's not polarity, though. That is going to be polar Perlin. Right. And by switching this over into polar Perlin for our polar caps, we should get a wobblier top and bottom. Let's find out. Well, we really reduced it. Let's go ahead and, so if I add 1 and then divide by 2, it becomes a value between 0.5 and 0. What if I want a value between 0.5 and 1.5? I could just add 0.5. All right, so now you can see it's a little bit wobbly at the edges. I can increase the wobbliness by changing the value on our scale here. So if I increase the value, we're going to get blotchier results, and that's kind of the point. I don't see a blotchier result. Huh. Well, I'm not 100% sure that that's working, but it works well enough for what I need to do for it now, so we'll go ahead and leave it like this. And that's sort of what I'd like to see. The polar ice caps could afford to be a little bit bigger. Let's go ahead and just make this a little bit more forgiving. And we'll also make this a little bit more aggressive. And let's run it one more time. There we are. So now you can see that our polar ice caps are starting to feel like proper polar ice caps. Good, right? So this is the sort of thing we can do by recombining these. And then when I want to not add the polar ice cap, I can just untick it and it won't happen. Similarly, the ocean, if I don't want an ocean, I can untick it and it won't have an ocean. So this can just be these here, but that's not really going to be very interesting. Continental plates on their own aren't terribly cool, but there are other things we can do. For example, we can create asteroid impacts. Meteor strikes large. Now, how do you do that? Well, all you need to do is blast a hole in the planet, and that just means that you're going to be lowering the planet a lot. We're going to use a low-end Perlin noise, and we're only going to take the, this is going to be just empty, and we're only going to, let's go ahead and actually add a new basic noise, because that one has stuff in it I don't like. So there we are. So we're going to go ahead and take this Perlin, we're going to go ahead and make this an add, we're going to apply it to all heights, and we're going to give it this kind of really aggressively sharp edge at around 0.6 or 0.7. And then we're going to bring it right back. We actually need to go down here for this, so it'll be like this. And then we'll bring it up really sharpish. And then we'll bring it over. Now this will move to the right because it's too far left, like that. And that will punch a big hole in the planet. And that's kind of the point. The problem is that I can't see it because I broke the run function for running for a specific noise element. So let's go ahead and repair that while we're here. we tell it to run for a specific proxy. Here it is. And what we do is we say to go through all the proxies in process, because we're very dumb. But that's all the pixels for all the proxies. It should work. Why doesn't that work? You're right, Elboechi, I'll fix that. Yep, I haven't gotten quite that far yet because I deleted it and stuff. Sampling proxy.name. So this should actually work. I'm not sure why it doesn't. That's really interesting. Not sure what to think of that. We'll have to work with that again later once I realize what's going on here. But what I could do is I can actually remove most of this for a minute so that we can see it a little clearer. Boom. And you can see that what this does is it creates holes in the planet, but these holes are oddly stretched. That's something I can't really avoid, but I can do better than this. There are a couple of ways to do it. The easiest way is to change our noise map so that it's even further to the right. Because the further to the right it is, the more it will just be punching holes rather than streaks. And that's more acceptable. Now, the problem with this approach is pretty simple. We don't have anything like streaks or anything that's cool happening here. But there are worse ways to handle this. So what we're going to do is we're also going to put in a negative divot right here at the end. Now, because we are adding stuff together, because we're subtracting, anything that's below 0 is going to be an addition. And this should allow us to create the edges of the impact. It doesn't seem to be doing very well, though. I can't see any sort of sign that this is properly getting set up. And that could be because it's not letting us go below 0 in the actual piece of the code which calculates out subtraction. I don't know whether it accepts colors that are negative values because we are fixing to a byte, right? If we go over here into texture proxy and we take a look, when we are calculating out values, if they go below 0, we're going to end up with values that are just 0. And then when we subtract them, it's not going to work out. So that's obviously not going to work. But what we can do is we can invert the values if they're less than 0. So here you can see that we got volume equals blah, blah, blah. And here we say if volume is less than 0, return. Instead what we can do is that we can say that if volume is less than 0, then volume equals negative volume. And we want to noise equals negative noise. And that should allow us to add things. The problem is we're still on adding and subtracting here. We may have to flip the overlay type. We will see here. Well, it sounds like my heat turned on. Yeah, we're going to have to flip the type here. If overlay.add, if sampling equals overlay.add, sampling equals overlay.subtract, else if sampling equals overlay.subtract, sampling equals overlay.add. But that will actually change our sampling value like at a core level. So we're going to want to make that a separate argument. So overlay operation equals sampling. And then here we'll just do that. Oh, sampling my butt. It's not sampling that I want. It's overlay. I'm just an idiot. Oh, I'm a fucking idiot. This is going to be overlay. And then this is going to be operation. There we are. So, and then down here what we'll do is we'll say that if those aren't true, then noise equals negative noise. That should work. Let's try it out. Grind, grind, grind. No, it didn't work. It might be just because this isn't a big enough, a noticeable enough dent, but that doesn't seem very likely. It looks pretty noticeable to me. Let's go ahead and make it really extreme. Well, we're definitely seeing something extreme happening, but it's not coming up. The tint by height should show us a brighter color here. We're not starting at a maximum value, so it shouldn't be done like this. It should be showing us the negative values here. Yeah. It looks like those are either all maxed out green or all medium green. I'm pretty sure they're all medium green. Yeah, that's definitely medium green, right? Well, let's go ahead and reduce this and see whether or not that value changes. So, yeah, it's a much darker green now. It's clear that this isn't adding, and it should be. How annoying. So basically, we want our operation to calculate out based on our noise, and what we do is if our volume is less than 0, we flip our volume, and then we also flip our overlay type. If our overlay type can't be flipped, then we invert our noise, because that's similar. So if we were overlay.subtract, we should switch over to overlay add, and our volume should be decent. And our noise value, I think I have to invert our noise either way, because our noise value isn't the raw noise value, it's the interpreted noise value. So we actually only do this, that's fine, it's fine, it's all good. Let's see whether this works. No, it doesn't work. What the heck? Well, if we were to switch this to add and see what happens, what would happen? So we don't have any holes around it. So it's clear that it doesn't work for add or for subtract. I guess our only option left is to debug it. Hurrah! So what we're going to do is we're going to go ahead and just type out everything that happens, right? Debug.log flipped volume to, and then we're going to give it the new volume and the new noise and the new operation. And then down here, we're going to go ahead and put in here debug.log subtracting. Oh, we're going to adding is what we want to put this in here. Adding our color. So with this in mind, we can go back over to the meteor strikes and set them up to subtract, and we should get a notification when they need to add. Okay, so that just didn't work at all. It's not ever subtracting, and I don't know whether that's because it is not triggering just due to grain, or whether this never happens. I don't think it ever happens. I think that there's something preventing it from having a volume of less than 1. That's very strange. Let's go ahead and have the whole thing have a volume of less than 1. Or a lot of it, at least. So it's never saying that the volume is less than 1. It's less than 0, rather. This is really weird. There's no fake noise map limit, is there? Where it's like, oh. This is the volume of the application, not the volume of the noise. You idiot. Okay. This needs to be noise, not volume. Yep, you were right. I was using the wrong variable. All right, so you can see that now we're subtracting and getting a very bright white result, and that's just because we are using this ridiculous curve that I made that makes no sense. There we are. So that should be a little bit better. Let's go ahead and pop that polygon back, pop that texture back up to a higher resolution. Aha, there we are. So now we have something that passes for crater impacts. Now it looks really bad when it's just on its own. That's kind of the nature of the beast. But there is one more problem with it, and that is that it's not actually very good at doing small meteor impacts. Let me go ahead and show you. So if we switch this over to small meteor impacts, I can just hide this guy. These small meteor impacts have a higher scale, like this, for example. But otherwise, they're very, very similar. But the problem is that the Perlin noise field only produces these little spotty results, right? So the options here are we either need to have a huge number of these, or we need to have a new kind of noise so that we don't have to sample it millions of times. So what we're going to do is we're going to add in a new kind of noise, which we're going to call a tri-Perlin. And basically this new kind of noise is just going to be the best result out of 3 Perlin calls. So for that, we're going to want to do a mathf.max Perlin noise pause x, pause y. Yeah, that's correct. And then we're going to want to have it offset by its offset. I can actually just grab it from here. mathf.max blah and blah. Should be correct. Any errors? No, I don't think so. Yay! So what we're going to do is we're going to switch over this small medium strike from Perlin to tri-Perlin. And that should triple the number of dots on our planet. Oh, it did not. That's interesting. That doesn't even look like it's the same scale anymore. Fascinating. I did this before and I didn't have any issues. I wonder if I did something stupid. It looks like the scale isn't properly being applied. So let's take a look. Did I screw up with the scaling here? Yeah, I screwed up with the scale. So I'm just not very bright. So now it should work fine. So we're going to reduce this back down to something like this. We don't need that super high scale anymore now that we're actually using the scale properly. Boom. And so you can see that this creates a lot of random crater-like impacts. They're not super circular or anything, but they're fast. I don't know of a good way to get them to be as super circular as you might want them to be. It just doesn't seem to be in the cards. Another thing we can do is, right now we are doing all of these at max scale. What we can do instead is come up with several variant positions. So vector 2 p1 equals pause times scale plus offset. And then here we can do pause times scale times 0.8 plus offset. Plus offset times 2 is fine. And then we can have a p2 and a p3. And this can be larger, like 1.2f plus offset times 3. And then in here, we can just use the p1, p2, and p3 instead, right? But we're going to want to p1, p1, p2, p2. Now the reason this is better is because it'll give us different size craters, which will be nice. P3, P3. So now if I run this, we should get several different size craters, smaller and larger, and that'll be a lot better for our overall crater-like hit appeal. Now, if we wanted to, we could set the scale quite low, like to 4, something like this. That'll give us a massive, massive set of craters that look like dongs. And this isn't necessarily bad. It really depends on whether or not we want to have a lot of craters and at what scale. However, this specific thing is called Meteor Strikes Small, so we'll go ahead and set that back up to, 14 or however we want that to be. And we're going to want to have this get applied. It's not going to be ice caps, it's going to be blast marks. And the blast marks are going to be relatively dark. I think that's better. And we're going to have them not be metallic. Smoothness is good though. So our applied height for these is going to be almost entirely at the 0 level here, like this. And that should allow us to get a darkened pits in our craters. We can modify this however we want, but in general, that's probably going to work out okay. So we can turn these guys back on, and what we're going to need to do is remove this biome and add in this guy. Copy component and then paste it. Like that. Now we can do both large and small at the same time. And obviously that looks a little silly, but you probably wouldn't use both at the same time. You'd probably use just one or the other. So you can see the sort of things that I'm developing. I'm developing a modular system for creating planetary setups. Here, for example, I can do the meteor strikes above the ocean because what I can do is then fill them in with ocean. So if I do that, then what I end up with is, boom, is a few really, really, really heavy dark elements in my oceans. Now, right now, the meteor strikes have an extremely heavy lip, which is far higher than they need to have. So we're going to go ahead and reduce that lip size quite dramatically because it doesn't need to be anywhere near that sizable. Alboetti suggests applying the large craters after the small ones. It doesn't really matter. I mean, it does, but it should look decent either way. The reason that the large and the small don't look decent at the same time is because the scales don't have any intermediates between them. So you end up with
like one or two big impacts and then a whole host of small impacts and no medium-sized impacts. So because of that, it ends up looking a little bit silly. There we are. So here you can see this is a planet where the meteor strikes happened fairly recently and blasted a hole in the planet. But they don't have to be fairly recent. For example, we could put the continental plates after the meteor strikes. And then if we run the planet, you can see the meteor strikes are almost gone. You can sort of see the crisp edges in places where it doesn't make a lot of sense. But you can't really see them as meteor strikes. They are just weird, crisp lines. That's too crisp. But what you could do is drop them between the raw continents and the roughened edges. Because that way you'll have the raw continents and you'll blast the raw continents away, and then the edges will get filled in. And the result there is that you have really, really sharp, crisp edges on the continents, but you still have the roughness of some of those values. We'd have to adjust some of these in order to work. The meteor strikes are a little bit too sharp for a soft planet like this. So what we might do is we might have a different variant. So this is meteor strikes large. This will be as meteor strikes soft. And what we'll do is we'll just take the noise map and we will soften it. And that's all we really need to do to make this meteor impact feel better. And if we do that and we drop that in here and we run this planet, there. Now you can see that the meteor impacts are substantially softer. We can even put them after our friend, the continental plates operation. And now you can see that rather than simply being a super crisp line, they're this interesting soft looking situation where they don't really blow away everything. They just kind of blow away a lot of stuff. I don't actually think this is soft enough. So we're going to go ahead and really, really soften it by flat out deleting this line here and then moving this line into a softer curve. And now you can see it's a really soft effect, maybe too soft. Yeah, that's probably too soft. Let's go ahead and strengthen that up just a touch. There we are. So you might be wondering, is this gonna produce planets that look fun? Well, the point here is that we're actually producing planets to be part of a game, and the game needs to have some fun elements to it. So right now we're just talking about the highs and the lows, but the point here is that you're going to want to click on notable regions of sameness. You're going to want to scout out these deep ocean craters or these huge forest biomes and stuff like that. So having these craters, first thing you're gonna do when you look at the planet is you're gonna say, oh look, here's a crater. It's an opportunity to find something interesting. Now the downside of this at the moment is that we don't have a minimum. We do have a minimum, so the craters can't actually go deeper than that. But what we can do is we can add in a new basic noise, raise it up to the top, and we can call this a raise planet. And this will be a flat add, which gets applied to heights based on their height, like this. Now, if we do that, then what we'll end up with is, that's probably much, much too high. Hold on. More like this, yeah. If we do that, then that means that we are setting a new height minimum. So basically, we're raising the whole planet up, and then we are punching crater holes in it. Now, the reason it's bright blue is because right now it counts as all shallows, except for wherever the craters get hit. So that might be a little bit too strong of a function. We'll just keep lowering this until it feels a little bit better. All right, so that gives you some deep water and some shallow water, and it can all be adjusted as we need to do it. To tell you the truth, this planet would be not totally fine. It wouldn't be perfectly fine, but it would be vaguely fine. One of the things we can do is here in the ocean, we have this basic biome for shallows, right? And we've got a basic biome for depths. Well, what we can do is we can actually adjust these values so that we have more interesting shallows. And the way we can do that is by adding in some basic noise between the two that has the same applied height, or roughly the same applied height, as our as this here. Unfortunately, I'm not aware of any ability for us to copy. We'll try it. No, you can't copy. What a pain in the ass. So this goes at 0.3 to 0.4. That's our focus. So when we apply a height here, we'll go ahead and set it up at 0, 0, and then 0.3 and 0.4 will be maxed out, right? Come on. And then these can be dragged in like so. And what we can do is make this a subtraction. And instead of using Perlin, we'll use Swirlin. And we'll reduce the scale sum. And we'll call this channels. Actually, we want to increase the scale sum. And that way we'll be dropping some of that shallows into the depths just before we apply the depths. So when we randomize this, we should end up with a lot of scribbly shallows. It looks like we don't have any shallows at all. That's interesting. It might be that I need to apply in a better noise map here, because I think that what we're getting is I think we're scribbling everything down into the ocean depths, and that's not what I want. There we go. So putting aside that weird part, which always gets a little strange, how does this look? Well, I don't see very much swirly stuff. These are the swirling marks, but they're not very pronounced. I think that I don't have a high enough... I really wish I could figure out what was wrong with my sampling, because that should work, but it doesn't. It should go through and apply all of the pixels with that proxy in our basic noise setup. When we're sampling, it should just work. Oh, but it's only setting the height. It's not set... Oh, here. The problem is that I'm not actually showing the height map. We forgot to put in the height map setup. Hold on a moment. We're going to want to make this always be height map pixels, I think. And then we can go ahead and just see how that looks. All right. So if that is how it actually looks, then that would be why we're not getting any decent noise here. Wait, this is the ice cap. God damn it. We were looking at the ocean, not the ice caps. There we are. So here it is. This is the swirly noise that we're trying to generate. These high values are interesting because we're not supposed to be using them, right? We're supposed to be subtracting, or do we have a if sampling always override? So if not sampling, then do this. That's good. So then we say otherwise, just set it to our color. Okay, so what we're doing here is we're actually showing our color, and that's going to be that these whiter values are going to be what we end up subtracting. And you can see that's just not as interesting as it should be. So I think the problem is that we might be a little too aggressive. That's not the right thing. We might be a little too aggressive on our noise map, because you can see how we kind of don't really give it very much space to work with. Let's go ahead and try it that way. That's still not very squiggly. This is really swirling. It looks a lot like Perlin. That's interesting. What happens if I change our noise map just like this? That should just give us a raw Okay. So I think what I'm going to do is give us a mid pass. Ah, that's more like what I want to see. All right. So with that in mind, I can then go ahead and increase the scale until it is the proper scale for what I would like. And then I can go up here and scale the whole planet. Boom. Aha. So this allows me to cut into the shallows, but you can see this cut is extremely sharp, probably too sharp. Well, we can fix that in a couple of ways. One is that we can reduce this from 0.1 down to like 0.5, and the other is that we can stretch it out so that it's not quite as sharp. And now when we run this, we might get a little bit better. Well, that was apparently too much. So that's down to 0.5. I think I'll just increase the scale. Well, at least it's interesting. Good enough, right? So what we've got here is the shallows are being swept around. I think what I want to do is soften this towards the lower end so that it cuts into the lower end as much as, as much as we want it to. Because as it is now, it's a little bit too hard. Yeah, that's a little bit better. This sharp edge is no good to me, and I think it's actually because of how we're applying the oceans afterwards. This ocean here has a pretty sharp drop that doesn't really feel very gentle. I don't know. It's gonna go ahead and try it out like this. That's better. Okay. So now we've got a brain-looking sort of situation. And I think that's mostly because our shallows color is really bright. So let's just darken it down. We don't need it to be that distinct. That's a little bit better. There are other options on how we could do that. We could use the alpha and apply it in another way. But you can see that we're getting something that looks interesting. Now, I've been focusing on the oceans so far, and there's no reason I can't focus on the land, so let's go ahead and start with some land work. Oh, that's not where I want it. Just go ahead and delete that. We'll go ahead and just duplicate the polar cap, and we will call this, what do you call it, mountains? Mountains. And what we're going to want to do with these mountains is we're going to want to put them so that our surface area looks good. So the first thing we're going to want to do is add in a basic biome that is dirt. Because then we're going to be modifying stuff, and we don't want to accidentally end up with block out white dirt, because that's not how it's going to want to look. So the applied height here is going to be anything like this is fine. There we go. And now if we do that, then we should see that it gets applied to most of the highlands. Yeah. So there's some beaches and stuff left, which we'll deal with later. But you can see that it also gets applied up here in what is theoretically ocean. The reason for that is because the polar cap needs to come last. So now if we do it, chaboom, perfect, right? So now what we've got is mountains, but our mountains aren't actually here yet. All we really have is some noise. Now the problem is I don't believe that these are very low. I think they're very close to being maxed out. So we're going to go ahead and flatten the mountains And that way we'll be able to get a little bit of working room to put some mountains in. Core activity says, what up? I'm making a game about planets. So here what we're going to want to do is get ourselves some nice mountainy feel stuff here. Core activity says, am I participating in a jam? Yep, I'm participating in ProcGen Jam, which you can find out more of by just Googling it. So I'm generating planets and letting people explore them, but I haven't gotten to the exploration phase. I'm still in the generation phase. So what we're going to want for our mountains is we're going to want to have something like this. And then we're going to want to have our noise map be a little bit crisp, maybe. I'm sort of trying to think about it, but if we sample this, we'll end up seeing that this is not very crisp. So we'll go ahead and sample it again. And we'll just keep changing the noise values here until we find something that we can get along with. So one of the problems is that these mountains are going to be not really ranges. They're just going to be like blobs. We can turn them into ranges by changing our noise map to a mid pass. Or even a low pass. Either one would work, I suppose. But if we change it over into a mid pass like this, and then we sample it, you can see that we have these long wandering edges. If we reduce our scale down until those are about the right size for mountains, we will have mountain ranges. Pretty easy, right? So what we'll do is we'll just go ahead and see how that looks when we run it. Boom. And you can see the mountains are quite soft. There's not really a lot of notable mountain elements here, and that is a shame. I think we need to maybe lower the planet more. No, it should be already quite low. It might be that we've lowered it too much. Let's go ahead and grab this and say that the maximum should be like 0.2. There we are. So now we've got some mountain ranges, and you can see that they ice over as they get up towards the poles. Now the problem with this mountain range system is that it doesn't really feel like mountains, it feels more like ridges. So what we're going to want to do is actually reduce those mountains right back down after we've created them. So we'll just do that right now. We'll have an apply to height like this. We'll make this a subtract at a fairly high scale. And that should work. Let's go ahead and see if it does. All right, so now we've softened them, but I don't think that was a high enough scale of basic noise. Let's go ahead and just see what the scale actually is here. Yeah, that's much too low scale. There we are, that's better. So now if we run this, all right, now they look a little bit more like mountain ranges. And of course, we can randomize it so that it looks however we want it to look. And you can see that they nicely get spotted up here when we start to put in our North Pole. We've got that weird crease in the back that I have to worry about. I haven't really figured out what's causing it, but I'll figure it out eventually. I still don't like the ocean at the moment. I think that it looks a little bit weird. And it might simply be that the color is too different. So we're going to go ahead and duplicate the colors just a little bit brighter so that we don't have to try and struggle with that, because I'm not sure that I like how that looks at all. And I might change it out later. But here we've got some mountains, and we don't really have a good feeling for any sort of other texturing on this surface. So here, before we actually do any of our mountain stuff, we're going to want to add in a basic biome up top here. We're going to call this one hills, and it's going to just subtract out. That's not a, sorry, wrong one. I didn't want a basic biome. I want a basic noise. Call this hills. And we're basically going to want to do a subtract of swirling. And we're only going to want to apply it to things that are pretty high. And our noise map is going to be pretty small. And we're just trying to get it to, how does that look? Maybe a little bit higher scale than that. Yeah. So once we have it like that and we run this, I'm just trying to get it so that it doesn't feel like it's just mountains. I want it to feel like it's got other kinds of terrain, but we've still got this very flat result. So I'm not sure whether or not it's just not taking. Well, one thing we can do is drop this above ocean, but we'll see how that works. Might as well see how that works right now. We dropped the whole planet into the ocean, basically, which isn't necessarily bad. We could adjust this however we want to. I think that what we'll do is at the end, we'll probably just add a flattening. So if we raise the planet, what we can do is just add in a flat value based on the current height and reduce this down to like 0.3, something like this. And that should just even out the surface a little bit better. Nope. I am about to sneeze this whole time. All right, so I think we're going to need to have this raising be a little bit more like that. That's interesting, because it should be high enough now. I guess not. All I can assume is that maybe I dropped it too far. I didn't, did I? This is only at like 0.2. Well, I did subtract out the hill noise. I'm not sure I even need to lower this anymore. Go ahead and remove that, and then we'll run it again. Well, that's interesting. We're getting some interesting stuff, but it's not what I wanted, so I'm just going to move this back down here, and we're going to run it again. So I'm trying to get the hills to work, and they're not working right now, and I don't know exactly why that is. They are supposed to be fairly small. I can go ahead and make them gigantic and see what happens. All right, well, now we can see the hills at least. So that means that what we can do is we can start to fill in the various biomes that we might want based on the mountains. So that's going to be a separate thing. So we'll go ahead and just separate that out. And we're going to call this Garden Planet. And we'll just remove a lot of these. There is one more biome that we do want to add in the mountains, and that's going to be the overall mountain terrain. So, mountain rock. And that's going to be a pretty bright color. It's not going to have much color to it, but it's going to be a fairly shining color. And we're only going to want to apply that to the highest heights. Like that. That didn't apply to shit. Let's try one more time with better heights. Actually, I think it did apply. It's just not a bright enough difference that it matters. Let's go ahead and change the mountains to just a color that I can see. Bright frigging orange should work. Okay, so no, it's definitely not actually getting applied. That's really interesting. Because those mountains should be quite high. They should be quite tall. Clearly, however, they are not as tall as I thought they were. Really? What's going on here? The garden planet is screwing it up. That's what's going on. This is not set up right, and it's just painting over everything like an idiot. That's almost certainly what the problem is. Yeah, there we are. Now we can actually see it. It's still pretty low, but I guess these planets are a lot less high. I moved them down on purpose to avoid getting them to be too high, but I didn't realize just how low I'd taken them. So now we're starting to add like ice to the top. It's not really the color I want, but it's not too bad. So what we're going to want to do is change this from ice to rock. We can add in ice later. And that should work, but I think we're going to want to do it like that. Yeah, that's a little bit better. We can live with that. Because that's not going to be the end of it. It's going to then have a garden planet applied to it. So the garden planet is going to be set up to handle the Midlands mostly. So we're going to go ahead and apply it to the middle of the planet. Like this. And we'll make this just a green. So you can see that what we've got here is it's being applied to the lowland elements rather than the highland elements, which isn't too bad. But it does mean that we have this situation where we've got this really weird green ring around everything. Vice versa, rather, highland elements, not the lowland elements. So we've got this really weird green ring. In addition, we're also populating the ocean with random streaks of green, which may be good, may be bad, but it's a little bit strange as it stands. So we're going to go ahead and try and limit that some so that it affects... I actually don't know whether we're affecting it too low or too high. Let's go ahead and make it real crisp and ask it again. I really should just put it on a show height map, but you know. So we are affecting the highlands, and we really want to affect the lowlands. I should make a height picker so that I can click on the planet and get the height for it. There we are. So that's creating some oceanic islands, and maybe that's good, maybe that's bad. But I don't think this green really works. Let's go ahead and darken the green. And what we're also going to want to do is add in some... so it looks like 0.4 is where the ocean starts. And what we're going to want to do is we're going to add in some compressive elements here. Maybe, do we want to lower the whole planet down? Trying to think of the best way to do this, because what we're going to want to do is have some polar purlin that will actually end up burning out the middle elements. And I'm trying to think of the best way to do this because not everything is determined by height. And so far we've done everything based on height. We may want to allow it to work with other values. But right now there's no way to store other values. Height is the only thing. I mean, we can store other values, but they're all biome based. What we really need to be able to do is to... Do we need a multi-channel height? We might need a multi-channel height. That would be annoying. I thought I could pull this off with nothing but height maps. It might be too difficult. Unless I can do like an extreme push where it just pushes all of the pixels out towards the extremes. Because that way I can work with the midlands. So let's go ahead and... yeah, let's go ahead and do that. So we're going to go ahead and create a new class. We're going to call this the Highland Shunt. And we'll go ahead and open that up. It's going to descend from texture proxy. And what it does is it moves all of the, moves everything above 0.5 height, or above listed height. Well, it just remaps heights. Oh, hold on. If it's going to just remap heights, let's name it something better than that. I'm so sneezy. Height remapper. Descending from texture proxy. And this will just remaps all planetary heights. And here we get the processing here. And what we need to do is get the height map. So float height equals p.heightMapPixels index.g, and that's our height. And then what we need to do is divide that by 255. So we'll just do float p dot blah 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 divided by 255f. That'll give us a value between 0 and 1, and then we move that through the curve. So do we not have a curve built in here? I don't think we don't have a curve built into this, so we'll just create one. Public animation curve height map. And down here we say height equals height map dot evaluate height, and then we say p dot height map pixels index.g equals, and we should have a float to byte, and we'll just pass it that. And that should work in theory. Let's see if it barfs. Anything barfing here? No. Okay. So if we do that, what we can do is we can take this garden planet and we can add in a height remapper as the first thing we do. And we can tell it to just make everything that is, just put it in the middle here. Yeah, so make 0.5 something that is rare. Oop. Push everything up towards 1 and everything down towards 0. Like that. Now that should allow us to have very different results here with this green nonsense that we've been cooking up. So let's go ahead and try it out here. Remove this for a moment. Okay, so you can see that almost nothing is currently green, which makes sense because I told it not to have anything near 0.5, and that includes 0.4. So all of our midlands are now gone. We've pushed them quite low or quite high. In this case, I think we don't want our height remapper to be based around 0.5, but instead around 0.4. And the reason for that is simply because 0.4 is where the edge of the sea happens. So if we have it translate 0.4 to 0.4 and then everything else gets pushed, we can have everything above 0.4 be land and everything below 0.4 be sea, in theory. And you can see that now we're starting to get a little bit of that green back. Of course, we can get a lot of that green back just by changing what the heck we're aiming at. So we might as well do that. And now we should have most of the lowlands green at this point. And that's not a big deal, but what we can do now is we can drop the mountain areas down a little bit and burn them. So to do that, what we're going to do is we're going to add in a basic noise with the polar purlin, but we're going to use an inverted noise map so that it is 1 at the equator and 0 at the poles. In fact, we're going to want it to be 0 quite fast, something like this. And then what we'll do here is we will subtract this, and that will bring down the height of whatever we're trying to do quite considerably. So if we lower this down to 0.5, that means that anything that we apply that's near the top is going to be dropped down, and this should bring a lot of the upper area down into the midlands. And then we can go ahead and burn it with a yellow biome, a dusty yellow biome like this. Desert. And that should be okay. We can just have it, I guess that's not really very yellow. Let's go ahead and make it notable. And then if we do that, we might see that it worked. Well, we burned the whole planet. Try to do a little bit less burning. Oh, I forgot to tell it to apply to a specific height. Brilliant! Right. So the height we're aiming for here is like 0.6 or so. And then we're going to want to drop back down, something like this. And we definitely don't want to go past 0.4. So probably like this is best. All right. So I'm trying to burn it, but all I ended up doing was changing the color of the mountains and not the color of everything else. And so that means that our lower end is a little bit too high. So just go ahead and lower it down. Oh, that's right. That's fine if we lower it down because we brought it to an extreme. I forgot for a moment. So you can see that we are steadily blasting down the mountains, but we're not getting any sort of softness into these holes, and we really want to, so maybe I do have to keep lowering this lower piece. At some point, it'll start to override the ocean, and that's when we need to stop. No, that's not working. I may need to rethink this a little bit, guys. I think I'm going to stop for here today, and what we'll do is I'll either run more this evening in a couple, maybe 6 or 7 hours, or I will have to think about this a little bit more. I think what we're going to need to do is have multiple channels for our biome work. I thought that I could just load everything into the height map by just shifting the height map up and down as I processed through the biomes, but that isn't really working out because it's difficult to keep things separated well enough. So I think it's going to make a lot more sense if I have a couple of different arguments. So what we'll do is we'll switch out to having 3 channel systems rather than 2. So right now, all of our, I guess I'll do some of it right now. There's no reason to wait too much here. Right now, all of our height map pixels are also our metallicity pixels. And instead, what I think we're going to want to do is have metallicity as a separate thing. And that way we'll be able to calculate out with 4 height map channels. So the height map is just going to just be its own self here. We're going to go ahead and say the metallicity is R. G is going to have to be something else, and B is emission, and A is smoothness. And the height map is just going to be an arbitrary set of height-like values, which we will track in a variety of manners. And this will allow us to work with various channels, and then when we're done working with channels, we can shunt them over into the basic height map. So for our height map, we're going to want height map to be the height map's alpha is the actual final height map. And that way, when we go to calculate out the bump map, we can use the height map, and then RGB will just be filled by whatever needs to be filled by. But until then, we need to shift over some of these values, because right now we're using the height map as height map, and we're going to need to have a separate metallicity map. And we're also going to want a height map. Is it called height map? Let's find out. If we go over to the planet and we ask this planet shader what it's called for its height map. So there's a bump map. It's called a parallax map, which is why we can't actually use it, because it's not a height map, it's a parallax map. But we'll go ahead and set it because there's no reason not to. Parallax map. Yeah, so that should work. Last thing we need to do is get this to actually have its metallicity set up right. And I think that does happen in 2 spots. Yeah, here's the other one. But this one doesn't matter, so that's fine. It's fine the way it is. So with that in mind, we should be able to do stuff. But right now, all of our basic noise fields affect the height map. So public enum height map channel, or target channel. Height 1, 2, 3. So with that in mind, what we'll do is, rather than setting just the G, or getting just the G, we're going to grab it from a setting element. So public target channel. And then we're going to need to have a public float get channel index, int index planet P. And this will just get the correct channel. We're also going to want a set channel int index planet P float value. Get channel, we'll just go ahead and do a quick little switch statement based on our channel. Default, we'll just go ahead and get alpha. So return our float val equals 0. And so here we'll just go ahead and say val equals p dot height map pixels index dot a. Break. Case target channel 1 R G B 2 3. And then down here we say val divided by equals 255, return val. And then down here we do the opposite. So byte val equals b to equals f to b value, and then we say switch blah de blah, and then what we'll do is we will just set this up so that it did a capital P. I don't know why I did a capital P, so a lowercase p. Equals val. Exciting stuff. So now we're going to use get channel and set channel instead of get height and so on. So down here in the process, this current height is going to be get channel index P. And then when we set our values here, our color equals this random thing, right? That's not what we want to do. We want it to be the correct color for our setup. We only want to set the channel that we want to set. So our color is going to be CCC. That's fine. And then what we're going to want to do is add or subtract the colors. But we're only going to want to change one of those 4 channels. So we're going to want to have the other colors all get reset to the default value. So to do that, we're going to need to be public color 32, keep one channel, keep our channel. Or color 32, our color, color 32, their color. And then we'll just do a quick little switch. So if it's default, we're going to go ahead and say that their color.a equals our color.a. Don't worry, these are not classes, they're structs, so we can do this without causing any damage. And we'll just repeat that process. And then we'll return their color. So this will be R, this will be G, this will be B, B, G, R. That should work. And that way we can just go ahead and set this up so that it's our color equals keep our channel, our color, their color, which is p.heightmap_pixels index. Oh, actually, this needs to come after the volume. There. So that should work, and it should only change one of the 4 channels based on what we want it to change. So with that in mind, the last thing we need to do is this planet is still caching G. So we're going to want to change this to A, just so that our visual shows up correctly. But that's fine. I think that was the only thing we needed to change. So we're going to want to just go ahead and hide all of this stuff while we play around a little bit. I guess we'll play around with meteor strikes large because that's pretty simple, just pretty straightforward to actually work with. And we will tell it to affect channel 1. Now our default color needs to be changed because right now it is 0 starting height, 0 100. It needs to be starting height, starting height, starting height, starting height. That's fine though. It shouldn't be too difficult. We'll go ahead and make this starting height into something like this, and then we'll run it. Let's go ahead and see what it looks like here. Oh, show height map, please. All right, so you can see that the height map is actually working fine. What we've done is we've subtracted from the red channel, which means that we've taken this from being a flat gray to being green at the points where we've punched down into it. And that is exactly what I wanted to see, so that should work. I'm going to have to start over with all of my calculations, but I know how to do them, so it's just a matter of recreating some basic work. And I can work with RGB in sort of an intellectual way that makes me that lets me remember what's going on. For example, B can be water. And then I can clear them if I want to clear them by simply subtracting 1 or adding 1 to the whole planet for any given color. So let's go ahead and just start over. Boom, nothing. We're going to go ahead and begin anew, afresh. And so this is going to be our continents. And we're going to want to create an empty object in here. And this is going to be, I think we're going to use a height map for our continents. But we do need another set of functions. The height map remapper, the height remapper here, works on, I believe, just the alpha. Or just the green, yeah. So we're actually going to want to allow that to work on any channel that we want. So public channel. And then here, we're going to want to grab the correct channel. So float height equals get channel. What do we call it? Is that only in basic noise? Because it needs to be in the base class. So we want to get the channel right here, and then we evaluate it, and then we want to set the channel. So easy enough. We're also going to want to have a channel translator, and that's a class that we don't have yet, so we'll create it. Channel crusher. And the channel crusher will just copy a channel from one channel to the other. So public channel. Oh, is it going to have to be descended from texture proxy, of course. Target channel source destination. We're also going to want to have a public operation. I didn't call it operation though. I called it overlay. And we're also going to want to have an optional animation curve remapper. So then what we'll do is we'll do an override process, and then we'll do basically the same thing we did for the height remapper. Except that what we're going to want to do is pass it a different set of channels. So this texture proxy, I did this height remapper without thinking about it. It's not going to work. And the reason is because we don't have a channel. So we're going to want to pass it a channel. And that does mean that we're going to be, I didn't call it a channel though, did I? What did I call it? Target channel. Don't know why I called it target channel. That's really pretty dumb. I'll probably have to rename that. Anyway, that does mean that we'll have to go over here into the channel stuff and actually grab it with specifying our channel. Yeah. And we're going to have to do the same thing here in the height remapper, so that's fine. Here in the channel crusher, we're going to be using two different channels, source and destination. But we actually need to get both of the channels so we can blur between them. And so what we're going to want to do is if animation curve, if remap dot length is greater than 1, then s equals remap dot evaluate s. And then what we do is we just do a switch based on our animation, on our overlay. Excuse me. Let me sneeze straight into the mic for you there. I'm sure that was just wonderfully pleasant. So if we're adding, we just say s plus equals d, break. Alboechi blesses me for sneezing straight into the mic on his watch here. And then what we're going to do is pass this d in. There we are. So this channel crusher will allow us to make modifications as we need to later on. But I don't think we need it right now. So for right now, let's go ahead and add in the basic continental noise that we want. Now that continental noise has a low value, a low scale rather, and that allows it to have just a couple of big continents. We're going to want to make the noise map something that gives us a little bit more control, and I think that is probably the best option for now. And we will go ahead and write that straight to height. The problem with writing it to height is that we won't be able to see it very well because that's an alpha value rather than an R or a G or whatever. So we're going to show the default height. The problem with showing the default height is that it's not going to end up real clear because it's only somewhat, it's only a partial element here. But you can see that we do have some stuff going on. So we'll go down here into this system here, and we will try to get this to feel a little bit better. And I think we can do that just by moving it up. Okay, well, that sample didn't take. My nose just decided to go, and now it's on its way towards just self-destructing. So here we have some continents, but I'm still not sold on them being quite right. First off, let's drop this into continents, because the way I did it before was me not thinking very straight. So if we do it like this, we can move it out even further here and see if we can get this to really work. Yeah, that's more like continents. We could also do something a lot more aggressive if we change this from Perlin to, or change this to add first off. We can change it from Perlin to tri-Perlin and then increase this even further. And that should get us some fairly interesting results. So here you can see that we now have specific swirls of different sizes. Now this is probably not quite the right size for what we want, so we'll just reduce the scale a little bit and maybe bring this up just a touch, like so. There we are. And then if we run this, so this is more or less the kind of planet continents I want, but obviously it's just continents. It doesn't contain any of the detail work that we need to make this feel right. So we're going to go ahead and add in some more basic noise. And this is going to be an edge roughener. And we're going to go ahead and make that scale fairly large. It'll be, I think Perlin is fine. Tri-Perlin might be better. We'll add, and we will apply to height something like this. And let's try it out. Okay, so you can see that we ended up with some wobbly oceans, and that's fine. It's a little bit hard for us to tell here right now whether or not this will work out, but I can tell you that the scale isn't very good. So we'll go ahead and increase the scale. That's better. And that'll roughen up the edges of our continents. Putting aside any silliness that we've got with the weird seam in the back. We'll deal with that later. So with that in mind, what we've got is just some arbitrary high points and low points. Let's go ahead and add in something which will burn holes in our seafloors. So we're going to call this a tectonic plates. And it's going to subtract and it's only going to apply to things that are already pretty low. And what we're going to want to do is have this noise map be a midpoint noise map that's fairly sharp, like this. And lastly, we're going to want to probably lower this scale. So let's go ahead and see how that looks. I don't know whether or not that even had an effect. So when I do this sample, it doesn't quite work anymore because of the way I've changed things. The variable metallicity has not been assigned. Oh, I forgot to actually create... Have I been working with that error the whole time? No wonder it's been a little screwed up. Metallicity pixels A equals color dot black. That's actually not very good. We'll go ahead and color 32, metal default. Because black is 100% smooth, like a cue ball, which would be a little bit strange. All right, so the problem right now is that if we do a process for a single proxy, we end up setting our albedo to the height map. And the problem is that the height map is alpha, alpha, alpha. I mean, it's only alphas, so you can't see anything. So what we're going to want to do is just do a quick little int index equals x plus y times width. And then we'll do a height map pixels index equals new color 32. And then we'll set it all to the alpha value of this height map. So byte height equals height map pixels index. Except for it's actually going to be whatever it isn't. Hold on. Yeah, let's go ahead and just set one of those values, like red. That'll work fine. Or we could multiply them. Multiplying them sounds expensive, though. Let's just go ahead and set red to it. So that way we'll be able to at least see it when we're processing it. Yeah, there we are. So we're trying to create some fun little trenches. Oh, we got a big ass set of errors. Oh, I know what the problem is. The problem is that we've got old cached crap that's not going to work. There we are. So it looks like I screwed that up somehow because only the tectonic plates showed up, and they showed up wrong. That's interesting. What's going on here? For some reason, this is the only thing we end up seeing, which doesn't really make any sense. That was strange. I wonder what was up with that, especially since now we can't see it. So you'd think that it would have worked fine, but it really didn't. So we're trying to apply it to a height where we can get it to look decent. So we're going to go ahead and stretch it a little bit more here. Where is it? This is really strange. Did I break something? I might have broken something because I'm not seeing any sign that this is happening. Yeah, see how there's not any sign that that's actually being applied? It should be. Let's go ahead and just set it to apply to all heights. The noise map, it goes to 1. Let's go ahead and set it to just a standard noise map. See what I can do here. It's strange that it's not working at all. Look, it's not being applied at all. It's just not happening. That's really weird. Well, let's go ahead and create the tectonic plates here. And then we can hide this guy. and just run the tectonic plates. Yeah, it's blank as a cue ball. Huh. This is odd. Did I screw something up when I changed how this works with the channels? Did I make it so subtracting no longer works? I must have. That's the only thing I can think of. So if we look at basic noise, if we look at subtracting, what we're doing here is we are saying that our color equals our noise value, our noise value, our noise value, our noise value. And then down here we say subtract, overlay.subtract. Our color equals subtract height map pixels index and our color, which will get us back C minus height map R, C minus height map B, G, C minus height map B, blah, 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 blah. And then we say that if our volume does not equal 1, then our color is partway between the base color and what we came out with. And then at the end we say to keep our channel. And this must be where I went wrong, but why would that only break on the subtract? That's really quite weird. Yeah, it's only broken on subtract. That is very strange. Why would it only be broken on subtract? Subtract colors doesn't subtract the alphas. There's the problem. All right, hurrah! That actually may have been a source for some of the problems I was having before. So our noise map, we're going to bring that back to being the mid pass again, because that's what we actually need. And our apply to height, we're going to go ahead and make that as before. God, Unity makes this really, really obnoxious. There we are, geez. Good enough. So now if we run this, all right, good. So if we turn this back on, and then we move this game object back into the continents. All right, so we do not actually have a very good tectonic plates setup, which is interesting, because what it should do is carve that out. Maybe I need to create these separately just for a little while longer until I figure out exactly what I want. Let's go ahead and hide this. Is the problem that we are maxed out here? I think it is. So what I've done is I've increased our starting height rather dramatically, and that bit us in the ass. There we go. So what I'm doing now is I'm scribbling all over the map, but it's not really what I want. This is far too high of a scale for what we need. We really need something like that, yeah. So let's go ahead and try that on for size. All right. So basically what we've got is some low noisy areas and some highlands that are very, very maxed out. Now, normally I'd be like, you shouldn't max them out, right? It's okay. We don't really care that much at this point. These are supposed to be continents, so what I'm doing is I'm planning to separate out the sea and the land. Now, it's not always going to be necessary, because lots of planets won't have a sea, but if you've got continents, you've probably got seas. So what I've done here is I have created the sea versus the land. And what we're going to want to do is just at the end of this continents section, we are going to want to burn all of the height map elements over into the B so that we can get that C-ness. I realized that sounded very strange. So store C level info. And so what we're going to want to do is we're going to want to transfer from height into blue. And we're going to want to have the remap be basically the opposite of what it actually is, like this. Maybe even just flat. Like that, yeah. So if we take a look at that, then we can turn on Show Height Map, and we're going to see blue. And that'll be fun. So if we go run this, oh, that's not blue. Huh. That's interesting. So I didn't expect that to not work. Run. If we take a look at the height map here, it does not have any blue values. So I'm presuming that our channel crusher doesn't actually work. Let's go ahead and take out the remap for now. See whether or not we can get this channel crusher to work with no remap. No, there's no blue here. So we should be setting the destination, but we're not. I don't know whether or not it's failing to set the destination properly or what, but S should be the source channel at the index, and then it should then just break because we're in override mode, and then we should set the channel destination at the index with S, you idiot. There we are. Found the problem. Let's do this again. So once again, let's go back into our remapper and put in the proper values. And let's take a look at our height map, because there should now be blue. Boom, blue. Look at all that damn blue. That's way too much blue. Why are you so blue? No, seriously, you should not be that blue. I presume that the problem is that No, that should be a fine. Interesting. Okay, so we're going to play around with this a little bit. We're going to drop down this to 16 by 16, and we're going to ask it what the heck's going on. Debug.log process. It's a channel crusher with a value of S. Let's go ahead and see whether or not it has something to say for itself. If they're all the same, we'll know what the problem is. They're all really, really big, but they're not the same. They're all 0.9. That's interesting. So if I were to debug log up here, S plus, comma plus D, we don't really care about the D, it's just the S. Not clear. So these are all values that vary quite wildly from 0.1 all the way up to none of them really get too high. 0.9, there's some 0.9. So, okay, we get the full range, but when we calculate the remap, it ends up being garbage. That's really interesting to me because the remap is just a very simple noise value. Oh, that's not 0, that's 0.95. Yeah, no wonder it wasn't working. I wish that Unity would scale these so that you could tell what was going on right away. But there we are. Now let's run it. Oh, let's remove the debug log. And let us punch this back up to 512 by 512 and run it. Shablooey. All right, so there you can see the oceans. Now you can see that it's not really very well preserved because our ocean limit of like 0.4 or whatever is catching a lot of the middle. So what we can do is just adjust this so that it feels a little bit more oceany. Something like this will work fine. We'll break here. Now it's okay if it's only slightly blue. That still means that it's blue. So we'll just run. Boom. So now we have an issue where I don't believe that our basic biome system can take an arbitrary channel. Nope. So we're going to want it to do that. Public target channel, height source. And so down here, when we get the current height, our current height is going to equal get channel, height source, index, and p. And that should allow it to work. Here you can see we're modifying the height map pixels, and that's not what we want. We want to be modifying the metallicity pixels. There we are. So that should allow it all to work out fine. And that should be the last thing we needed to fix before we are ready to create various masterpieces. But I think that that's plenty of time for today, at least for this morning. I may or may not stream later. If I do, it'll be long after those of you in Europe have gone to bed, presumably. But thanks for hanging out with me for a couple of hours and watching me fiddle and fuddle with this planet to try and get it to work. 3 hours have passed, and I am actually worse off than when I started, but I now have the foundation that will let me do complex channel math. And I also worked out some of that complex channel math in my head, so I shouldn't have nearly as much problems when I sign back on to do more stuff later. Alboechi says that if his phone notifies him, maybe he'll wake up. We'll see that. I'm not entirely sure that would be a good idea. Feel free to sleep through this stuff. But I am going to take about 5 more minutes and just do the very, very first take on making this channel stuff work. And the reason for that is because I want to have a screenshot. So we'll go over here and we won't show the height map anymore, but we will use the height map's elements to set up the ocean. So our basic biome here is going to be ocean, and we're going to set this up with a biome color of a deep, rich blue, like this. And we're going to want to apply some metallicity and some smoothness. No problem, right? We're going to want to apply it to a height that's actually the inverse of these curves. It's a little bit of a shame that they are only available in increasing. Are they? Can I get the decreasing version? Oh, there. New. Huh. So I can, in fact, create my own presets, which I'll do later. So the height source here is going to be RGB, channel 3. I can also change those names if I want to. If I decide that 1, 2, 3 isn't as good as RGB, I can change them and there won't be any problems. They'll automatically work. There we go. And you can see that what I've done is I've created some ocean. Now this ocean is not as crisp as the other ocean, and that's pretty much fine. But what it does do is it cuts into the continents pretty aggressively. So one of the things we may want to do is crisp up those continents more aggressively than we have been. And that would be here with the edge roughener. We've got this thing where the edge roughener doesn't really roughen the edges quite right. What I'd like to do is have it work like this. And we'll see whether or not that helps. Well, it doesn't seem to help any. In fact, it seems substantially worse. But the question is whether or not it's worse. Which way it's worse here. Oh wow, that ended up being weird. Let's go ahead and clear out all of the other channels when we're processing, okay? Oh, it's albedo channel? I'm an idiot. Obviously, it's not the albedo pixels. It is the height map pixels. Oh, for fuck's sake. I'm doing everything wrong here. This is the process map. That's not where we want to do this stupid crap. It's in here. So we're going to want to set this up as color black equals color 32 black. or equals, my bad, new color 32. My brain just shut off. I don't know if you could hear that, like click. But we're in here. We're going to go ahead and set this so that it is correct. Perfect. So now we should be able to see the noise without the rest of the nonsense on it. There we are. And you can see that this is not how I want it to look at all. What we're going to want to do maybe is move this up. Let's find out. That might be better. It's better, but I think the scale is just bad. That's a little bit better. Let's go ahead and see how that looks. Yeah, that's a little bit better. I mean, there are things I could do that would make this a little bit better or a little bit worse. Not really sure yet, but what I think I might do is duplicate this. Oh, I just duplicated the tectonic plates. I don't need more tectonic plates. What I can do here is roughen up the edges again using a higher grain and using subtract. With that should work more or less, with the noise map being more or less the same. If I take a look at the values here, it'll be there. That's good. Whoa. I thought that was set to subtract. It is. Because that's clearly not subtracting shit. It's clearly adding. Why is it adding? That's really, really weird. All right, well, let's... That's interesting. Why is it adding? Don't add when I tell you to subtract. What's going on here? Apply to height. So it should apply mostly to the taller areas. That's fine. But the noise map should be... I mean, why is this... Let's go ahead and make it really, really basic. And nope, it's still adding, I think. Pretty sure. So tectonic plates should be subtracting as well. But they appear to also be adding. That's... Oh, well, the tectonic plates... No, these should both be subtracting, and instead they're not. This is not great. I've gone ahead and clustered them all, and I probably shouldn't have. So let's go ahead and uncluster them. Okay, so if I were to remove these guys, I would be left with just the edge roughener and the tectonic plate. Well, what's going on here? For something that's only supposed to have the edge roughener and the tectonic plate, you sure have a lot of crap. What's going on here? Here's the tectonic plates. Okay, so the tectonic plates are pretty aggressive. But if we take a look at what's happening here, those are deeper. So it is subtracting. But the question is why the edge roughener isn't subtracting. If we were to duplicate this, we could then remove the edge roughener. And you have it only be the edge roughener here. And see what the heck's going on, because that's really weird. Run. Yeah, it's definitely adding. Let's see whether there's any difference when I switch it over to add. Oh. Okay, so it wasn't adding. I was just being dumb, I guess. No, hold on. That can't be right, because when we switch it over to subtract and we run it, there are still points that are higher. I guess maybe that's because they are being applied to a height differently. No, that's never really below 0, except for maybe at just a little bit at the bottom. This is just a flat setup, so this can't be the problem. So let's turn continents back on and see what happens. All right, so it's definitely subtracting now. I don't know whether or not it's always been subtracting and I'm just a big goof or what, but definitely the problem here is that our noise map is too sharp. So we're going to bring this down to like 0.5. That way we should have a little bit less monstrous hole stuff punched into our planets. So you can see that we still have some fairly hole-based approaches. I think this is a little bit too... I'll do it like this. Perhaps it'd be a little bit better. You can see that it needs to be applied a little bit more judiciously to the center of our height map rather than just to the top. Alboechi says, shouldn't the alpha on black be 0? No, I made it so it was 0.5. Sorry, alpha on black is 0, but when I'm displaying it here as a graphic, it's at 0.5 so that you can see it. So middle gray is an alpha of 0. And you're right, Alboechi, those points were the starting height, and that was, in fact, the problem I was having. So here's what I get when I work with them more aggressively. And if I turn on our next continents section and run that, then I carve these massive swaths out of it. And I think it's pretty clear that our noise map needs to be considerably tighter and only apply to a smaller amount of size. Because you don't have tectonic plates in the middle of a continent normally. All right. So now we're carving out some depth here. You can see that happening. But because the deep areas aren't really very deep, we aren't getting very much depth there. So I'm going to switch over into having it be a neutral height when you start. And that should make it so that the depth is more noticeable. Except that it really didn't. That's interesting. Is that because we are now too tight here? Maybe. Oh, it's because we're too tall. I told it to only process on very, very low-end stuff. So we'll just pull this out and move it up a little bit. There we are. So now we've got some tectonic plates happening. I don't know whether you can even see those on YouTube, but they should be pretty clear on our system once we actually get started. So let's turn the oceans back on and try it one more time. So you can see that right now we have a pretty high height map. And the reason for that is because we're starting at neutral rather than at close to 0. And because of that, when we're adding our noise maps for our values, we're getting maxed out very, very rapidly. So we're just going to reduce the strength of those additions so that we don't have to max out quite so fast. So both of those are now at 0.5, which is probably more like what we need. No, that didn't help any. So we'll move this down to 0.4, and then we will move this down to 0.4. Actually, this is probably the problem child right here because of the way this curve immediately spikes when it shouldn't do. And now we'll run that. Why are you all higher now? I made it so that both of these should be lower. They now max out at 0.4 and at 0.5. But for some reason, they are getting worse rather than better. Look at that. We're actually rising. We're getting taller. That doesn't make any sense. I'm reducing the amount of height we're adding, so how are we getting taller? What? Alboichi says, am I accidentally filling the continents with water? Core Activity says, music? Did I accidentally put some music on? Because I didn't mean to. I don't hear any music, Core Activities, so I think anything musical is coming from your side. So if I look at the oceans here, I am applying the height of the oceans. Let's go ahead and just turn this off, and that'll give us raw height. Okay, so you are right. I was filling the continents. That's really weird. So these darker areas should be lower into the ocean. And I've actually modified it so much now that it's really sharp and ugly. So we'll fix that. Nah, still pretty sharp, but I think we can bring it back. I moved all of these things too low to try and fix what I thought was the problem. It turns out that wasn't really the issue. So we're going to want to bring some of this back under our control here. There we go. Now we're starting to get back into it. So if we then turn on our show height map, we can see what the blue is. And we can see that the blue is out here. So I'm not sure. Oh, I'm just an idiot. Right. So I inverted the blue twice, and that's the problem. It should really look like this. There we go. That feels more like what I want. Right. Good. Good. So now the problem is that this this edge roughener I've got here is a little bit too strong for the heights that it's at. And that's not a big deal, because what I really want to do is pull this back down. Like that. Because I don't need to screw up my continents by punching holes in them. There we go. That's more like it. Core Activity says, no, do you need any music for the game or any art? I don't really think so. I mean, if you're real good at pixel portraits, I'll be drawing maybe a dozen of those, and you could draw them for me, I suppose. But I've got music, and I can draw the pixel art myself in a couple of hours. So I'm not too desperate to coordinate with anybody. So wouldn't worry about it. Right now, I am just going to take a screenshot of this and then sign off. But thanks for stopping by, everybody. I think I am going to do one last thing here. I'm going to duplicate this and move it to the side. I guess my snap is turned way, way up. And then what we're going to do is have this not have a height map, because otherwise it'll overwrite the other height map. There we go. Core Activity says, pixel portraits? Yeah, don't worry about it. This is not a very big game. It's not really worth worrying about too much. If you wanted to, you could talk to me about it later, but I honestly don't think it's worthwhile. I mean, this is something I plan to pound out myself in just a couple of days, so I don't think I'll need any help. But thanks for the offer, and I will see all of you some other time. I'll probably stream again tonight, finish up our planet generation system, at least marginally, and then we'll move on to actually clicking on shit. And won't that be fun? But first, I've got to go I don't know, play, do other things. It's Saturday. I'm not going to stay inside and stream all day. Have a great day, everybody. And where is that stop button?